Today we're going to talk about the specific heats of common materials table found on the front cover of your reference table. Let's remind ourselves what specific heat actually is. Specific heat is a measure of the amount of heat energy needed to change 1 gram of a substance by 1 degree Celsius. We actually see that definition in the units for specific heat that are represented right here. So look at the units, joules per gram degree Celsius. What does that mean? It means that specific heat is the amount of joules, the amount of heat energy needed to change 1 gram, that's our measure of mass, 1 degree Celsius. And by the way, I'll throw in one other symbol here. Specific heat overall is represented by the symbol, a capital C with a little p. So you could see when you want to calculate specific heat, you're going to need to be working with joules per gram degree Celsius. Now, what we see from the table and the numbers that are listed here, different materials, different numbers, we see that each material heats differently. So, for example, the number for iron, the specific heat of iron, is 0.45 joules to raise 1 gram of iron 1 degree Celsius, versus, I'll pick dry air, which takes 1.1 joules to raise the temperature of 1 gram of dry air by 1 degree Celsius. So it's like twice as much to change temperature in dry air than it is to change the temperature in iron. Even if we go to the same material but different phases of the same material, like we see right here at the top, this is all water, H2O, but whether it's in liquid, solid, or gas, the water vapor phase, we see that there are actually different numbers for specific heat, different amounts of heat energy needed to change temperature in those different phases. Now, as we look at the numbers, we're going to notice there are those that have the much lower value for specific heat. So those would be down here towards the bottom of the listing. These all have the lower values for specific heat, lead, copper. When you have a low value for specific heat, that means that it takes only very little energy to change temperature. Lead takes only 0.13 joules per gram degree Celsius to change temperature. Therefore, when the value of specific heat is so low, that's the easiest and the fastest material to change temperature in. Go up to the top of the table, where our numbers are much higher, all the way, matter of fact, to the top. Liquid water has the highest number that we see here on the table. That's 4.18 for its specific heat. That means it takes 4.18 joules of energy to change the temperature of liquid water, 1 gram of liquid water, by 1 degree Celsius. So when you have the high value for specific heat, it takes a lot of energy to change temperature, and it would therefore be the hardest to change temperature and would be the slowest to change. So just looking at the numbers without doing any computations, we kind of understand something about the relative amounts of energy needed to change temperature in these different substances, and also whether it's going to happen faster or slower. Now, what if you were actually asked to do a calculation to come out with how many joules of energy is needed to accomplish some kind of temperature change? Well, let's try an example using the table. Here's our table again, but I'm going to give you a formula. You can reason it through, but the formula is really easy. So I'm going to write it down for you, and then it's easy for us just to plug in some numbers. The formula that we're going to use is Q, which is going to be our measure of heat energy that we're ultimately trying to figure out. Q equals mass. We always need to know how many grams of a substance we're working with, times the change in temperature. How many degrees of temperature change are we trying to accomplish here? So that's in that part of the formula, times the value of specific heat for that material. All of those important numbers that we need to plug into the formula need to be given to us either on the table or in the problem itself. So let's try a problem. Here's a typical one that we might see. How much heat energy is needed to change the temperature of 4 grams of granite from 15 degrees Celsius to 20 degrees Celsius? And a part 2 of the question, is this heat energy being added to or taken away from the granite? So let's do the calculation, and then we'll worry about the part 2. The question says how much heat energy. We are looking to find out the Q. That's our heat energy. Do we have the information that we need for mass? You bet we do. It's right here in the problem, 4 grams. Do we have the change in temperature, the delta T? Yeah, it's right here. From 15 to 20 degrees Celsius. That is a change of 5 degrees Celsius. That's where we'll get our measure of delta T. And finally, for the CP, for the specific heat, well, they're telling us we're working with granite. So that means that we're going to focus in right here on that measure of specific heat. So let's write down our equation. Q equals M delta T CP. Let's plug it in. We're solving for Q. We have the mass out of the problem. It is 4 grams. We're going to multiply that by our change in temperature, which is going to be 5 degrees Celsius. We multiply that by our measure of specific heat for granite, which is 0.79 joules per gram degree Celsius. That's a heck of a unit. But here's where the magic happens, because we get to cancel out. The degrees Celsius cancel out, the grams cancel out, and we are left with only one unit, that is joules, and that is what our measure of heat energy should be in. Let's just do a little bit of arithmetic. What do we find? We find that we have now 4 times 5 times 0.79 gives us 15.8, and our units, joules. 15.8 joules of energy are needed to bring about the temperature change in 4 grams of granite from 15 to 20 degrees Celsius. So we've answered the first part of the question. Okay, it's right there. There's our calculation. But what about the second part? Is this heat energy added to or taken away from the granite? Well, to figure that out, we go right back to the temperature change. In this case, it went from 15 to 20 degrees Celsius. The temperature increased. To increase temperature means to increase the energy level. Therefore, this heat energy must have been added. So the energy was added because your temperature increased. If the temperature change had been, say, the exact opposite, from 20 degrees Celsius to 15 degrees Celsius, the calculation would have looked identical. We'd still be having 15.8 joules of energy involved, but if the temperature went down, that energy would have been taken away from the granite. So to figure out added or taken away, just look at the temperature change? Did it increase or decrease? So whether you need to actually do a straight out calculation like we've just practiced, or you're just going to reason through some of the information we talked about looking at the data on the chart, you can handle it either way.